Good afternoon, everyone, and welcome to IBM's webinar DevOps Without Firefighting, using AI driven observability to achieve faster releases and lower MTTR. I'm Namrata, your host. I'm a tech writer and an AI researcher. And joining me as a co-host is Charles Lobo. He's the head of engineering at SalesboxAI. He has deep expertise in DevOps and related tech. So glad to have you here, Charles, with me.
Glad to be here. Glad to be here. Exciting webinar is going to be. We're all
Right.
looking forward to it.
Absolutely. So we have a packed hour ahead, and we have three amazing practitioners from this field, and four discussion blocks. We'll have live polls, and of course, we'll be hearing the audience questions as well. So there's room for everyone today. A few quick things before we start. Chat is open for reactions, so Charles, keep an eye on that. If we have any questions coming up, we'll address them at the end of our discussion. So hang on for the questions. You'll get all your answers today. And the session is being recorded, and you will get the recording after our 1 hour session ends. And I think we've all joined at a very critical time in 2026. And we are going to talk about one of the few more very practical and real problems related to enterprise DevOps. How do you stop firefighting and start operating with confidence? And I think let me set the stage with some numbers. 43% of DevOps teams say they spend too much time responding to alerts, not because they are slow, but because the alerts are noise. So they categorize it as noise, actually. And during my research, I also read that 73% of organizations have had actual outages caused by alerts that were ignored because engineers stopped trusting them. So, but I think we'll again be addressing all the challenges in this field. And let me quickly introduce the speakers who will be closing all the gaps in the DevOps operations with us. So, our first speaker is Mohit. Mohit Agrawal. He's a segment leader for IT automation and FinOps at IBM. He's leading the go-to-market for Instana, Turbonomic, Concert, and the broader AI ops portfolio. And he is an IBM Golden Circle 2025 winner. And let me remind you, that's the top 1% globally. So very honored to have Mohit with us today. And Mohit, thank you for being here. Welcome to the webinar.
Thank you. Thanks a lot.
Nice. So let me quickly welcome our other panelists also. We have Vaishnavi Bhatt. She's the brand technical specialist at IBM. So she's going to ensure that our conversation today is practical, not too much theory, because she knows all this in hand, that she has that kind of knowledge and hands-on expertise. So Vaishnavi, thank you for being here. Warm welcome to you as well.
Thank you.
All right, and our practitioner voice, very, very important face on our panel, is Vineet Chauhan. He's the CTO at Pramerica Life Insurance. He has about 22 plus years of experience across DevOps at scale, from Vodafone Idea to Bajaj Allianz Life. And he has built and rebuilt DevOps practice at scale, which is what I researched when I was reading his profile. So very glad to have him on the panel today as well. And Vineet, over to you.
Yeah, thank you, Namrata, for the welcome. Great to be here. Thanks.
Thank you. Thank you all. Thank you for joining in, and thank you to all the attendees who are quickly seeing the numbers. So thank you for being here. And let me get into our first theme. But I think instead of me, Mohit will be the better person to open the floor. He has a very nice presentation for all of us. And Mohit, let's set the stage for our audience.
Thank you, Namrata. I have prepared a very small presentation to just set the context, and let me just share my screen here.
Okay.
Is my screen visible?
Yes.
Just a second. So thank you everyone for joining us today and taking time to join us today. So I am Mohit Agarwal. I am the segment leader for IT automation and FinOps pillar. Our today's discussion topic is very simple. So the DevOps team should spend less time on firefighting and spend more time on innovating. So with the help of the AI driven observability, we will see how it can be made a reality. So before getting into the presentation, let me just ask you a very simple, one quick question. You all would be running a lot of say business critical applications. Have you ever experienced any application slowness or the outages? You may post your answers in the chat window. And I know the answer is yes. When that happens, so how quickly can you identify the root causes of the performance issues? In many organizations, in the absence of the modern observability tools, the clients, so they get into the various teams get into the firefighting mode. They start blaming each other, like say the server team blames the database team blames the network team blames the third party APIs, and after say a lot of say number of hours and a few say bridge calls and a few cup of coffees, we get to know that the code was broken. And meanwhile they all the time has been wasted, and the customers say the customer transactions have been impacted, and the business leaders also asks for the updates, and the DevOps teams a lot of times a valuable time goes into identifying the root cause of the problems. The problem today is that is not say the organizations are not today short of the data, they are short of the context. So our today's discussions focus is primarily to, with the help of the AI driven observability, how can we move from the firefighting mode, the constant firefighting mode, into the say proactive operations and achieve faster releases and lower MTTR. With that, let me get into the what we are going to cover today. So this is the agenda that we are keeping. We will be talking about first the industry trends shaping the observability market, the common customer challenges, and what is the proposed solution here, the key differentiators. We will also cover a few say clients that love Instana and the analyst recognitions. So let me just take a step back and see how the application landscape has evolved over the last few years. If you talk about say last say some 5 to 10 years ago, the applications were built on monolithic architecture. They were deployed in hybrid, in say single data center with the limited API integrations. But and suppose now something say fails, it was quite easy to understand which application has failed, which server is the problematic, where the problem is happening. But now the world has changed dramatically. Now these days the applications are built on microservices based architecture. They are deployed in the hybrid cloud environment. What used to be single application is now say thousands of the services that interact through the APIs. Now suppose if any transaction fails, the problem can be say in any microservice or say in container or say in any server or database query or in the third party say APIs wherein we don't have any control. So this is the reason the traditional say monitoring tools are not sufficient enough to address the new age requirements of the organizations. So this is the reason the world is moving from the traditional APM tools to the full stack observability platforms, which can help you in correlating your matrices, events, logs, and traces. And we are also seeing the rise of the Gen AI driven observability to support the intelligent automation and root cause analysis. The another trend that we are seeing is about the shift left approach. What I mean by that is that the organizations are now building the monitoring into the CI/CD pipelines so that they get the idea about the, say, the performance issues before they reach the production. Finally, there is a, say, the standards like, say, open telemetry are gaining a strong adoption for vendor agnostic telemetry. So all these trends are driving the need for the modern observability tools, which can automatically discover the environments and deliver the contextual insights. We have been speaking to the clients across the globe, and we have come across a few common customer challenges. You can let us know if they resonate with your business as well. You can just post your replies in the chat window. So here, say as we talked about, the organizations are now, say, they have deployed their applications on the microservices based architecture, on container based architecture. The deployments have happened on the hybrid cloud environments. They lack the visibility on their complete end-to-end stack. This is the biggest challenge that they are facing. In addition to that, they are facing the high MTTR, mean time to repair, that is very high, because they are using the different tools. All the tools that, say, like the application team may be using the different tool, the infrastructure team may be using the different tools, the clouds teams may be using the different tools, they may be using the native capabilities of the various hyperscalers, and now all these tools are not providing them the single pane of glass, because that is a reason they are getting the fragmented kind of the view, and which is not leading to the the extraction of the root cause of the performance issue, which is leading to the high MTTR. And then some of the tools, they use the sampling. Because of the sampling, they are not able to, say, monitor their applications on, say, real time basis. Like I can give you an example for, say, on, say, yearly basis, or say on in 2 years one time we go to the doctor and we do our full body checkup, and now we get to know that this is the vitamin, I have a deficiency of, say, vitamin D or, say, B12, and the doctor prescribes me the medicine. Now this is kind of the sampling that we do after, say, every 6 months, or, say, after 1 year we are going to the doctor for our full body checkup. But these days, now also we wear the electronic gadgets which monitors my health on, say, per second basis. Something if happens to me, if my, say, the heartbeat suppose reaches more than 200 per minute, and I'm not doing any workout, so it will send an alert to my emergency contact. So this is the kind of the monitoring, the observability the electronic gadgets are doing today. And for our, say, the IT systems, we are still relying on the traditional kind of the methods. Another challenge is that the rising operational cost with the inefficient tool chains. As we talked about, the organizations are using the multiple tools and which are not able to give them the single view. They maintaining all those tools is increasing their operational cost. Then finally, they are not able to correlate their matrices, events, logs, and traces to get the actionable insights and to get the root causes of the performance issues. The business impact is that the SLAs are getting breached, the revenue loss is there, the brand reputation also goes on the toss, and also there are certain, say, regulatory obligations which the organizations have to meet, which are also getting breached. Now, what is the solution for that? The solution that we are proposing here is IBM Instana, so which provides you the enterprise-wide observability of your complete IT stack, including your all the applications, your infrastructure, your services. So if you start from, say, it is primarily built for, say, hybrid multi-cloud platform. You can, say, observe all the digital channels, including your mobile apps, your websites, your all the cloud providers, including, say, your IBM Cloud, Azure, AWS, all your cloud and virtualization platforms, your all the OS, IBM systems, It also supports more than 300 technologies. You name it and we have it, including your all the runtimes, your OSS collectors, messages, your web proxies, IBM technologies, and also it has 6 comprehensive capabilities. Auto discovery. So what I mean by that, so if you deploy Instana agent on the server, it will automatically discover all your say microservices, your all the databases that you have deployed, all the OS or say all the open source components that you have deployed. It will provide you the complete view on that. Then it provides you the vertical and horizontal context. Vertical context, what I mean by that, from server to the code level, it can provide you the visibility. On horizontal level, all the microservices based say context you can get. Thousands of the microservices we have talked about. It will provide you the view on thousands of the microservices. Then it also provides you the application perspective. From all the people, there is a single data model that this tool uses. So business people or the DevOps engineers, they will get the single view. Pipeline feedback, like we talked about, the CI/CD, the Instana can be deployed in the CI/CD pipeline so that you get to know about the performance issues before they go into the production. Then you can do the root cause analysis as well. And it also has the say the a few say standard dashboard, and also you can build in the custom dashboard depending upon the requirements of your organization. And it provides you the single data model for all the different domains that an organization have, like your business operations, your DevOps teams, your security ops teams, your IT operations team. They all can get the single view, and if something happens, any performance issue happens, they can get the view on that. This is the another slide on the architecture view of Instana. Here we have talked about a lot of things, and but the primary thing is, which is of the interest for the audience here, would be the use cases. It can monitor, it can do the application performance monitoring, your website monitoring, your mobile app monitoring, application monitoring, synthetic monitoring. What I mean by that, now suppose you are running a campaign and you are expecting on a one particular day, you are expecting that there may be some 10 million customers that may hit your website. You can simulate your website in Instana, and you can do the load testing in Instana, how your website will behave if such kind of load comes on your website. Then you have the service level monitoring, Kubernetes monitoring, serverless monitoring is also a part of that. Then infrastructure monitoring. And the heart of Instana is dynamic graph, which helps you to map and correlate all the components that your complete IT stack has, like your all the microservices, your containers, your servers. It can map and correlate, and then you can also get the blast radius. Suppose something happens, some performance issue has happened, you can get to know the impact as well and where this problem has happened. So there are a few value props. So the first value prop of IBM Instana is that it monitors, it observes your complete IT landscape with 1 second metric granularity. So which is very important because the containers, they are being created every second and they are getting destroyed also in your environment every second. So in case you are not observing with 1 second metric granularity, it can create the blind spots and you may not be aware of the performance issues which may have been created due to the containers. Then it can do the root cause analysis. There are more than 300 plus supported technologies. Then it can do the anomaly detection. Also, it can help you if there is a issue because of the say code. If the code is broken, it can tell you about that as well. Then the most important thing is about the predictable pricing. In case of most of the tools, their prices increases as you scale up. In the beginning, you may end up say with the contracting with say 100 rupee, but after 6 months as you scale up, you may be paying 200. By the end of the year, you may be paying up say 300 rupees. Whereas in case of Instana, it is based upon the number of the virtual servers, and the pricing is fixed. In the beginning of the year, we will get to know the total number of the physical server, the virtual server, and the worker node basis that we can give you the per unit price, and this price will be fixed for the whole year, even if you scale up. It is not based upon the memory or CPU utilization. So we have the customers in all the sectors, domains, all the big names like SBI, Indian Bank, Kotak Securities, Muthoot FinCorp, Bajaj. So they are all using IBM Instana. TCS, Infosys are some of the other customers. And all these say analysts like say IDC, Gartner, Trust Radius, G2, they recognize IBM Instana as a leader in their reports. And thanks a lot. This was, I thought that let me give you the 30,000 feet view of IBM Instana. If you want to have a, if you want to book a live demo, you can just scan the QR code. And also, if you want to say see experience the capabilities and features of IBM Instana, there is a barcode for the sandbox environment as well, which you can view. And so this is all about my presentation. Over to you, Namrata, again.
Well, thank you, Mohit. You set the perfect context, I think. And that's indeed a very advanced solution. And you also listed the value props also of Instana. So that was quite valuable, I think, for our audiences. We also have a poll going on in the background, and I believe answers have been filled in. So while that exercise happens, I think I'll hand it over to Charles. He'll be taking up the next topic with you guys. It's AI-led observability and intelligent anomaly detection. So over to you, Charles.
Thanks, Namrata. So yeah, what we're going to discuss now. Thanks for that overview, Mohit. It was really good. It made a lot of sense. And from there, I'd like to take you up. Maybe I'll talk to Vineet that Mohit talked about. How is it extending into business? If there's a latency spike, does it actually have revenue impact? Is it real today or still aspirational? How is it going?
Yeah. So I think really critical. So I all my career I have been into the companies which consume technology. So as the technology leader in those companies, it is my responsibility to make sure that technology serves the intended purpose, right? So the heart has to be at the right place. So while a lot of projects and programs are shiny toys that everybody wants to do in terms of doing large scale transformation projects, but at the end of the day, it is the bread and butter of the organization that runs the company. So from that perspective, it is really critical to make sure that the systems run perfectly in production. And if there are issues that are going to happen, they are proactively identified, timely action is taken, and the tech team is able to prevent it rather than an issue happens and then you do an RCA and a fix. Because whatever you do, whatever little time there will definitely be either the customer impact or a financial impact or a reputational impact, and in the worst case regulatory impact also. So it is really critical. So one bit I would want to add here is the approach that the tech teams need to take in terms of when they think about DevOps as a whole. Normally, when the tech teams start thinking about it, they start thinking about infrastructure monitoring, CPU, memory, storage, utilization, alerts, etc. Or maybe in terms of the application, API response time, and so on and so forth. But in my view, the starting point needs to be the business deliverables. When an application or a service, rather, I would not say application, when a service is running in production, it is serving a business purpose. Number of transactions that are happening, number of checkouts happening, payments, orders being placed, So that should be the starting point, and from there you decide what all things that needs to run perfectly in production to make sure a good user experience, be it the customer or the employee. So from that lens, it needs to be looked at, and then the appropriate criticality and importance to be assigned in terms of service, application, and the monitoring.
That's actually really insightful, Vineet, because I guess most of us don't do that. Most of us start, as you're saying, with the actual alerts and what CPUs are required and all. But it's actually business impact that makes a difference. I think that's a really great insight we need to take. And talking about alerts and all those things, maybe you or maybe Mohit also would be able to come in. When you talk about alert fatigue nowadays, as you said, there's microservices, lots of alerts coming in. How real do you find this problem on the ground? And what point does it actually become a business risk?
Yeah, so Charles, I would take it because I have been watching this for last 22 years. There are so many alerts, there are thousands of the alerts, and I have been telling my teams all my life if if you cannot prevent an issue, too many alerts is as good as not having alerts. If you have so
Exactly.
many alerts
The
that a
boy who
lot of
cried wolf.
people, you are getting hundreds of the emails, and in the morning you will come and select all and delete them. Or these
Right.
days, Microsoft automatically categorizes them spam and goes to that folder. Then
Right.
it is better not to have those kind of alerts. So, in
Right.
my mind, three things are important when you think of proactiveness and hence the alert and the monitoring. One is action orientedness of an alert. Every
Mhm.
alert must have some actionable. If you don't know what is the action that will follow after that alert is useless. Number one.
Mhm.
Number two, there needs to be absolute clarity within the team who is the primary action owner of that alert. I have seen so many times that alerts or all those three levels that we talked about are defined, and rightly they are sent to application team also, business teams also, the infrastructure team also, and everybody thinks that somebody else is working on it. So it needs
Right.
to be absolutely clear that who is the one person who is responsible for that alert. It needs to be very, very clear as to what is the action that is going to follow for those alerts to be effectively utilized. You might build the
Right.
best, systems, best monitoring systems, but if they are not consumed properly, it is useless. So I think if these principles are followed, the deluge of alerts can be really avoided.
Right. Especially ownership is a really important concept because otherwise anybody can, say, I didn't think it was for me. It was somebody
Yeah.
else's problem. Right. Absolutely right. Mohit, is there anything you'd like to add on to that?
Yeah, Charles, let me give you an analogy. So, say what I was going to say, Netaji Subhash Place from Gurgaon, and I got to know that there is a huge traffic. Like say on Dhula Kuan, there are three roads coming. One from Karol Bagh, second from Bikaji Kawa Place, third from Gurgaon, and all these roads were blocked, chalked. And now these days we have the CCTV cameras also on say in various places at all the traffic lights and also all these points like the important areas like Dhola Kuan. Now the traffic control center was getting the view of that there is huge rush, but
Mhm.
they are not able to get the view where the actual problem is. What is the
Right.
root cause of the problem? They were not, because all these feeds that were coming from the various cameras, they were not able to give them the single view. There were different
Right.
views that they were getting, and they were not able to correlate those. And this is a reason they were not able to know that there one accident has happened near say this Delhi area, near say this Narayana flyover. Some accident has happened. Now the ripple effect has happened that all these three say main roads are now blocked. So this is
Mhm.
a similar scenario that we are getting in the IT systems.
Right, I agree. That's what Vinit was pointing out, that you need to have clear action items, what's going to happen and who's owning that thing. Otherwise, it's just noise that's coming in and you don't know. Anyway, based on the person decide what to do,
Correct.
right? Vaishmi, would you like to give some insights from your side? Like all these alerting as we are talking about, how is it different from, say, context-aware insights? Can you walk us through some examples?
Yeah, so when we get an alert, a regular alert, it just tells. Now, for example, let us take an example of a fire in a house,
Mm.
right?
Mhm.
Or in a place in a society. So it is just like a regular alert will be there is smoke somewhere, but a context aware alert will be like when was the fire started, where exactly is it, and who is affected. So this is
Mhm.
how you get this is the difference that you get between a context aware alert and a regular alert, and this in turn will also help in reducing the noise, that is the spam alerts. Like Vineet sir said, we keep getting a lot of alerts, but if we know if the tool can do a combination, or when it gets some context aware alerts, it can combine a set of alerts and give a single alert telling this is where the alert is, this is what happened, and maybe this is because it is happening. Now, for example, in a real life scenario, in a banking transaction, at one particular point in month end, for example, there'll be a lot of financial transactions happening, right? Because of the salary
Right.
distribution. So this might also lead to an error or an alert in a monitoring tool telling there is a lot of CPU usage going on, right? So but this is because it is month end and there are a lot of transactions going on, and that is why you have that extra utilization of CPU. So this should
Right. So
not
there will be a
be an
CPU
alert.
spike,
Yes.
but it's not a real spike.
Yes, it is not really a real spike. But if a
Right.
tool gets to know this, that every month end this is going to happen, and accordingly, if it looks at the alerts, then we also get a reduction in the alerts, and we also get context aware alerts, and that's how we can also get to the root cause as soon as possible.
Interesting, interesting. Thanks a lot, Vaishnavi. That's very insightful. Okay, so I think let's, Namrata, maybe you can ask some questions as well. We take a next section of maybe looking at root cause analysis as Vaishnavi put up. Maybe we can ask some questions to the panelists on that.
Right. So I think we've established that how AI observability can see the issues. Now, we need to talk about when something actually goes wrong. What is the next step, right? So I'm coming to our next topic, which is accelerating root cause analysis. So I think this is where most engineering hours actually go. Detecting the anomaly is only half the battle, and figuring out what happened and why it happened is the next battle, right? So let's dig into accelerating root cause analysis. I think I'll begin with Vineet. So the question that I want to ask is when a production incident fires today, let's say, in a complex distributed system. So can you walk us through what a manual RCA process actually looks like and where most of the time gets lost?
Yeah. So Namrata, I would rather like the participants to reflect in their organizations. I'm 100% sure they would have felt this, that whenever a big incident happens and it is not very obvious as to what is broken, everybody would likes the senior most architect to be in the war room to try and give that insight and resolve that issue quickly. Now let us try and think about it, why that criticality or importance of that senior most person is there. To my mind, the reason is the person has the understanding of the overall architecture. The person knows how the data is moving from A to B to C. What are the dependencies? What are the reasons, factors, overall business context? And that's how probably those senior people are able to pinpoint the exact problem faster than others. So that is the probably the reason. Now, in AI world, imagine a system which is equivalent to that senior architect who understands one business context. As Vaishnavi mentioned, there are business seasonalities, who understands the overall flow of the system, who has the whole data of the telemetry, who can understand, as Mohit explained, the tools which have the telemetry up to the second. And on top of that, complete view of what all changes has happened in terms of what the deployment has happened, has any configuration change happened or not, so that a holistic 360-degree view context of the ecosystem is available to the person. So then it becomes really, really easy to pinpoint that this is the problem. At least, zooming into the specific area or ruling out rest of it becomes that much faster and better. So I think with the solution that Mohit proposed, I think these kind of AI assisted solutions can become really, really helpful in quickly doing the RCA and hence fixing it faster. So I'm really looking forward to it. We'll discuss about it and see how we can infuse AI assisted solutions to do the RCAs very, very quickly, rather than doing those things, the way it has been done traditionally. Namrata, as you said, it goes to one person who is the impacted party, owner of the application, whichever breaks down. So everything is on his head. He will try to figure out whether it is an infra issue. He will call 10 people in the war room. People try to blame, shift the blame. Not my system's problem. Seems to be your problem. a DBA will come say my database is running fine, I can't see any queries being blocked and so on and so forth. And after a lot of tug of war, and finally something comes out. And by the time we are losing critical revenue, customers' experience is getting impacted. So I think these kind of solutions can really help trim down the whole journey and do the RCA very very fast.
Yeah, I agree. I think a lot gets lost there. Mohit can also add something to this, I believe.
Yeah, very beautifully covered by Vineet. This is the typical scenario that we face across the industry because, see, as of now, there are many organizations which have not onboarded new modern observability tools. So, in the absence of the modern observability tools, a lot of time is wasted into, say, identifying the right teams. They are using the different tools, so getting the say different kind of data, then correlating the fragmented data that the teams have provided from the various tools, then also understanding the business impact and eliminating the false leads, so wherein a lot of time is wasted. And if you have a say AI driven modern observability tool, all this time you can say save, and you can directly identify the root cause of the problem, and then you can quickly resolve them as well.
Yes, I think you both of you painted a very real war room picture today, and it begins to get more complex as we go, as we deep dive into it. So I think Vaishnavi, let me come to you and slightly change the topic. Go back to an incident, CrowdStrike, July 2024. So that took down 8.5 million Windows devices globally. Now, what do you think? How does AI observability helps teams understand that the blast radius of a bad deployment? How does that help to determine that faster?
Yeah, so when an incident occurs, like the CrowdStrike incident, it is a very good example of why we need modern observability, right? A context-aware observability, or something that will correlate the logs, existing alerts that come, logs, traces, and metrics, where we have even a distributed tracing platform. So when this issue came up, it was not like what went wrong was not the first question. The first question was, what are the different systems getting affected? What are the clients that are getting affected? And what is the business impact on this, right? So that is where the blast radius takes a huge role. And for this to for us to cater this problem properly, what we have to do is we'll have to have the capability of getting a view of the entire blast radius, or the impact analysis basically of the entire infrastructure. And this will happen if we have a single pane of glass for monitoring both the infrastructure and application components, be it some of the infra metrics or the database metrics, or some of the application components like the instrumented runtimes, or the proxy servers that are there. So that is where we get to know where exactly each and every transaction is going on, from the endpoint service to the authentication platforms, and then to the customer portals as well. So this will also help us get a horizontal and vertical context as to if they're running on clusters, then what pod or what cluster it is running on, what is the server that it is running on, what is the infrastructure dependent on it. So if this blast radius or a correlated view, if it is given, then it will be really helpful for us to get to know what exactly is the issue, and we'll also get to know where exactly to stop right now, so that not more of the business processes are affected. And the second thing is tools like Insana, since they monitor with 1 second granularity, none of the transactions are missed. And upon that, they monitor even your deployment, since it is integrated with your CI/CD pipelines. They will monitor the deployments. Even before deploying, they'll monitor even the canary releases. So whenever you go for a release, if something is wrong because of the release, then you can get to know the change of behavior even before it reaches the end customer.
Yeah, so I think those are very core technical advanced capabilities inside Insana. Now, since we have AI everywhere, so I think we definitely had to include a block related to that. So let's talk about agentic AI. So my next question is related to agentic AI. Vineet can answer that. I think where AI doesn't just diagnose but autonomously remediates, right? So where are we today in that spectrum, and what guardrails must exist?
Yes, I think we are at the beginning of it, honestly, and especially in the financial services sector. There are a lot of other prerequisite needs to mature to that extent that this really becomes the mainstream. Some experiments I've seen in the industry, people doing on automation to begin with, maybe to begin with a bit of observability, addition of some features and functionalities, but full-fledged usage, I would say some time away. But maybe Mohit can add more details through his experience with other industries, how it is happening and what is the way forward.
Yeah, so let me start with the example. We were working with the life insurance company, and therein we had proposed this. So here, like, just take an example of at 2 p.m. So Instana, like the observability tool, has put forth the requirement that the system needs more compute at 2 p.m. in the night. Now there is nobody at 2 p.m. in the night, and then there is a say another agentic AI tool which can provision more compute at that point of time, and in the morning when the employees came back to the office at 9:30, they got to know that there was a problem at night at 2 p.m., which was taken care of by the system itself in the automated manner.
Oh, okay.
So this was a good use case for the insurance companies, and the banks, and the BFSI segment is an early adopter for these kind of the tools. So what I think that we are moving from AI as an observer to AI as an advisor, and eventually in selected scenarios to AI as an operator. But we are not yet at a stage where enterprises should hand over the all the keys entirely to the AI. Today,
Yeah.
most of the organizations are, say, comfortable with the AI helping them detect anomalies, correlate events, and recommend the probable root causes. The
Right.
next stage is assisted remediation, where AI suggests the next best action, say.
Right.
And
Right.
the final stage would be the autonomous remediation, where AI executes those actions without waiting for human approval. So in this life insurance company also, we didn't say that you automate all the actions. What we told them that with time you will learn, and there are a few actions which you can automate basis the experience. So where are we today? So most of the enterprises are somewhere between, say, assisted diagnosis to assisted remediation. In low risk scenarios like, say, restarting the non-production server, it is certainly yes. But if you want to, say, stop the core banking system, it would be a very big no.
Yes. Yes.
And what are the guardrails that you are, say, talking that need to exist? So I think there can be four critical guardrails. One, the explainability. AI should explain, and then the policy based automation. You have the experience basis that you have automated certain actions. Then the auditability. Later on, it should not happen that you are not aware of who has done that. Then the agentic AI, the adoption should be gradual, not in one go. It should be gradual. So my take is agentic AI should automate the toil, not the judgment at this point of time.
Excellent. I think, yeah, I also believe in that human supervision,
Yeah.
and I understand the suspicions. So, thank you for your answer, Mohit. So now, one of the most common conversations I think I have with DevOps leaders is tool sprawl. So that's our next topic, reducing MTTR without tool sprawl. So every team adds a tool to solve a problem, and suddenly the stack is itself a problem. So I think, Charles, you have hands-on knowledge in this aspect. So let's discuss that also with our panelists.
Yeah,
Over to
yeah, of
you.
course. Yeah, it's actually one of the more interesting aspects, especially for insurance, Vineet. As you would know, you deal with legacy core systems, like huge amounts of legacy core systems, and you're spanning the whole gamut from legacy systems all the way now to the new AI, the latest cutting edge systems. So how do you achieve like observability between all of them without ripping out legacy stuff and replacing it whole square? What do you
Yeah.
do to handle such a complex system?
Yeah, so Charles, absolutely real problem at hand because most of our kind of organizations have these two sets. One modern digital stack, we call it system of interaction, be it employee, customers, or partners. And on the other hand, legacy applications like policy administration systems, which are legacy systems. So some of them are COBOL-based, mainframe-based kind of applications, and they don't really support that degree of integration. The overall movement is also slow. So yes, there is a challenge, but there is. So what we have tried to do is we have tried to create a layer on top of both of them, which will get the telemetry from both kind of systems and create a unified view for our DevOps teams to be able to see the holistic picture in terms of telemetry, in terms of tracing, in terms of identification of the problem. And then correction probably is not that unified. So once you have identified this is a problem, the rest of the team takes over because both sets of ecosystems are completely different in that sense.
Right.
So that's how we are trying to manage these two disparate nature of systems.
So would these tools be more in-house developed or they are, more purchased?
So as of now, it is all in-house,
In-house.
and there is a certain degree of strategic call that we have taken, that we have done it in-house. But we
Mhm.
are always open for collaboration, learning new things, and as Mohit was mentioning, infusing AI in those things. It can be in terms of buy a platform or in terms of building a platform using AI. Both are okay.
Right. So Vaishnavi, do you have any inputs on this? Like how would you handle a tool sprawl like this, such a huge, gap in technology?
Yeah, I agree with Vineet, sir. So, in such cases where we have both legacy systems and modern systems, what we can do is we can add a layer of instrumentation, right? So, this particular layer, this is where we can support both the modern applications and the legacy ones. So, the modern applications, they get the telemetry data. It supports different agents and distributed tracing metrics. And we also have these correlation platforms as well. But when it comes to legacy systems, we have different kinds of code languages where most of them are not even supported in most of the tools, right? In such cases,
Right.
what we can do is we can try to expose the telemetry data of these legacy systems, some signals like through either logs or some batch jobs or SNMP traps or even the MQ events and system metrics. All of these can be put into this instrumentation layer, and these signals can be ingested with the observability tools in a common model, along with we can also use open telemetry as well if the
Right.
legacy systems support that.
That's fascinating. Yeah, it is a complex problem. Like Mohit, what would you say about these? What's the cost of all these tools? These tools, besides just the license fee, how do these disconnected tools actually increase time to recovery rather than reduce it?
So, Charles, I believe that the real cost is not only financial, it's the cognitive. They kind
Mm.
of say you are using the organization is using the different tools. The application team says that whenever any problem occurs, application team says that everything is okay. Infrastructure team says that yeah, everything is okay from our side. Network team also says that everything is okay. And even they, if suppose the organization has already onboarded the hyperscalers, they are using their native capabilities also. So there also the signals are coming and everything is okay, but we are not able to identify the root cause here, because the real problem is we are not able to get the single view of the feeds that we can get from all the tools. Like I had given you the example of the traffic. So here again, we may not get to know about the root cause of the problem. So this is the biggest reason that the teams spend a lot of time in identifying the issue, and the hidden costs can include, say, slower incident response, the duplicate investigations, increased alert fatigue, higher onboarding complexity, and ultimately reduce the confidence in the operational decisions. So full sprawl fragments the visibility, and also unified, say, observability accelerates the understanding. That is what we can say expect from the tools like IBM Instana.
Agreed. Okay, that makes a lot of sense. And talking about tools now, of course, everything is in AI, so we have a lot of AI tools going in. With this AI tools, we have faster and faster releases. But lots of developers now say that because of these AI tools, we have an increased blast radius of bad deployments, and so we need much more observability than before, right? That would be a good topic to take up next. So we'll discuss faster releases. Namrata, if you want to take in some questions.
Yeah, I think that ties in everything together as we move closer to the end of the session. So, we've discussed better detection, faster diagnosis, fewer tools, and I think that ultimately serves one goal, which is enabling you to ship with confidence, faster releases with greater confidence. So, I think I would like to ask Vineet. Now, I've read that Dora says that high employment frequency and high stability are not opposites. You can have both. Why does it still feel counterintuitive, and how does AI assisted observability change what's possible in regulated environments?
Yeah. So Namrata, again, few basics that I would want to put on the table. For many years, everybody in IT have been talking about two concepts: the monolith versus microservices based applications in terms of the application architecture, and the other in terms of ways of working in a waterfall way or in an agile way. And both are being experimented at different levels across the organizations. So that makes a very big impact on the confidence or the frequency with which you can really deploy the changes, release the products, make the features ready. So it is much more easier if you have a microservices based architecture and you follow agile philosophy. Then makes a lot of sense in terms of having such observability tool also which have you back. So in terms say typically I release every week, but if I have that kind of a model and I can release multiple times a day. I heard somewhere that Amazon releases hundreds of the changes every day. It will be unimaginable for a life insurance company, obviously. So it depends on, so everybody will have to take decision on for themselves as to where do you stand in terms of this. So it definitely helps that if you are want to make release faster and you are releasing smaller chunks, if it can be quickly identified, you have a very good tool which can tell you here is the problem. It can be quickly identified, remedied, and the blast radius can be minimized. The impact is minimal. And once you have that kind of a confidence, it has a cascading impact on the kind of assurance you want in terms of system integration testing, in terms of UAT and production release. So the whole cycle gets benefited because you have the confidence that if something goes wrong, the blast radius will be minimal and it will be quickly identified and it will be quickly remedied without really having too much dependency on the people. So that is the whole cycle, I believe. But there are other, counterintuitive perspective that I would like to give here to the audiences. There are certain things which are specific to the industry. Say, for example, some regulations tell you that how a particular, say, product release in a life insurance company, it cannot be released in patches. A product might have 20 modules which are getting impacting the life cycle of a policy from issuance to servicing. But the regulation says that it needs to go in one go, because you cannot release a product and not your servicing part is not ready, or it will be coming later. Not possible. You have to do it in one go. So if you ask me, this is a question that every organization needs to answer for themselves in their specific case, and maybe partially implement the sections where you have a supporting architecture and your processes are aligned, then you can definitely go with it, and it's definitely going to help.
Right, that was a very sharp response, and I wanted to add more, but I'm afraid we're running out of time also. So we have a lot of questions from our audience, and Charles would also like to read the results from our polls. So let's quickly hop on to there, Charles.
Yeah. This has been a very, very interesting webinar. We've got lots of really
Absolutely.
insightful things from all the participants, Vineet especially, and Mohit and Vaishnavi have given really great inputs. I'll read up a couple of the questions, but before that, let's take the poll results. One of the really interesting ones is DevOps pain point is slow root cause analysis, that which ties in with everything everybody's been saying so far.
Right.
Mohit says that everything needs to be, together. Vinit has pointed out the fact that too many alerts are coming, and so that's obviously the reason we are just handing over things from left to right. So obviously, solutions like Instana would help there. The second poll showed that 60% of people of organizations are already using AI in some form in their, in their current DevOps, which is quite interesting actually. And the adoption speed has been incredibly high, right? And out of the remaining 40%, 20% have mentioned that they are planning to in the next 12 months. So it's there. It's on everybody's plate and everybody's mind. This is the best time to be, looking at this space. Some questions from, based on the feedback we've got is somebody was asking how do organizations embed monitoring? Like I think we believe that left shift that Mohit had pointed out into the CI/CD pipeline. So Mohit, if you want to give some more information into that.
Yeah, I also wanted to ask that. So yeah, we can touch upon that briefly.
So I think it's important to recognize that we are on a journey here. Historically, observability was largely a post-production activity that we all agree. Now, say these days, observability insights are increasingly being embedded into the software delivery lifecycle itself. So that before even say this goes into the production, you get to know about the performance issues. So AI driven observability can analyze the historical incidents, the deployment patterns, the dependency relationships that may represent the elevated risk. Now, for example, has this service experienced instability after say previous releases? This kind of information can be say we can receive from the AI. These signals
Right.
the engineering teams make more informed decisions before the release decisions.
Right, that makes sense because we all know that certain things always are, most dicey than other parts of
Yeah.
our system.
So
That's a good point.
that now we are say this shift left approach. We are embedding the AI driven observability into the CI/CD pipelines so as to get the say the performance issues before they get into the production. The goal isn't simply to deploy faster; it is to deploy with the greater confidence so that later we don't need to do the firefighting.
Right, agree. Good point. And I'll take like one more question, or should we just wind down? We're very close to the end.
Yeah, I think we can pick one.
All right. So one more question we got was, can AI ever be autonomous for remediation, like completely autonomous? Do you see it somewhere down the line?
So I
So
think I'll take that and slightly on a lighter side. The kind of background you see on Mythos and Fable and those kind of
Yes.
things, you don't know what is going to happen next month. I don't know what will happen in June. So maybe I would have said probably that no, it will not be autonomous for 5 years up to 2 months back, but I am not so sure now. Maybe it will happen.
Yeah, nobody's sure now. That is absolutely right. We don't know what we don't know,
Yeah.
basically. Right. Okay, great. I think let's go to wind down because we've got 2 minutes left.
Right. Amazing ending question, and thank you, Vineet, for ending the session on a slightly suspicious note. But I think we are heading into such times, so don't blame anyone for that. Thank you, again, Mohit, Vaishnavi, Vineet, for sharing your time, your expertise, and your real world stories. I think they'll stay with me and our audiences. And a very big thank you to Charles also. You moderated the session really well with me and for bringing that energy.
Thank you,
And our
Namrata.
audiences, yeah, you were very active during the session. So thank you for sending in your queries. And we couldn't take all of them, but maybe like Mohit said, you guys can connect with the IBM team later on for any specific queries related to Instana. And the recording will be shared with all the attendees, so don't worry about missing out on anything. But thank you for being here live during the session. That means a lot to the IBM team. And we'll also share some resources with you post the session. So I think my closing notes are stay curious and ship with confidence and stop firefighting. So, and any closing thoughts from Mohit, Vaishnavi, Vineet? The floor is open.
So the final thing from my side is don't use AI to become better at firefighting. Use AI to make firefighting unnecessary. Thank you. Thank you, Namrata,
Very good, very good.
for this lovely session.
Vaishnavi, Vineet.
Thank you, guys. This was a
Thank you.
really nice interaction and a lot of good things that came out. And I really love the way you summed it up, Mohit. Absolutely. Don't do the firefighting, make sure that the fire itself is not there. Absolutely.
Right.
Yes, absolutely, absolutely. Thank you so much, Vinny. Thank you so much, Mohit. And of course, thank you, Namrata, and sorry, thank you, Vaishnavi, and thank you, Namrata, for hosting this beautifully. We had a very nice and very exciting session. The
Yes.
recording will be available, and we really thank you for being a part of it. All of you, all the
Thanks,
attendees.
guys.
And the
Yes.
participants.
Have a great the next part of the day. Friday is already here.
Yep.
All
Okay,
right,
bye, guys.
Bye.
everyone. Good luck.
Bye.